So I just solved this flying pig problem that I made up this quiz question. There's a pig that has wings and flying around in a circle supported by a string. I give the length, I give the mass, I give the tension in the string, and the question is, how long does it take to go around, and how fast is it moving? So one of the things I want to do is use the same idea to model this in Python so we can actually see the pig moving around. I just think it'll be a nice little art project. So I'm going to use some of the visual elements in Python. Let's just jump right into it. I'm going to use these calculations over here so that we can change the values and see what happens. But let's just get started. So I don't know what I'm doing. I'm doing this from scratch. So if this is a disaster, then I don't know what else to say. Okay, so let's start off with a ceiling. So I'm going to say roof because I can't spell ceiling. I can't remember how it's spelled. Let's say top. Top equals box. The position is going to be equal to, I want it to be shifted up some. I guess I should give some constants up here first. So let's say g equals vector. Actually, I'm going to just do g. So there's actually two ways you could model this. One is to kind of set it up and just animate it, and then you could calculate it. Or you could actually replace the string with a spring and let it play out. But I don't really need g as a vector because I've already got a model. So I'm just going to say g is a scalar 9.8. L equals 15 centimeters, so 0.15. M equals 0.25. And that's all I had. Okay. So I want the box, I don't want to put the box at the origin. I want it to be kind of centered on there. So let's say the origin is in the middle. So the position of the box is going to be up in the y direction. So it's going to have a 0 x coordinate, L over 2, 0. So it's going to be shifted up. Now for the size, it's going to also be, these are, make this bigger. These are standard VPython things. The size is a vector. I need to give it the x, the y, and the z length. Let's say L for the x, for the y, L over 10. Yeah. And then let's say the z is going to be L over 5. And let's leave it as gray. So let's just run this and see what it looks like. Okay, so there's my ceiling. Now, I want to attach my string somewhere, and I don't want to use the position of the box because that's in the center of the box. I'm actually going to make a new point called a pivot. And it's a sphere. It's going to be really tiny. Its position is going to be equal to top.pos, which is the vector location of that, minus top.size minus vector 0 top.size.y over 2, 0. So it's going to shift down the length of the thickness of the box. And then I'll give it a radius of something small. Let's say it's going to be L over 20. L over 20 divided by. And I'll leave it, let's make it, should we make it yellow? Nah, let's leave it. Let's see what happens. Yeah, okay, so there it is. So let's make that a little bit smaller. Let's say 50. That's where I'm going to attach my thing. But now I can reference that position, and it won't be inside the box. There's my, oh, it's a little skinny. That's fine. Okay, now let's make the pig. The pig is going to be a sphere. Okay, I need to actually calculate theta first. Remember, I had tension up here. T equals 5. That was from the problem. I gave the tension. So I need to calculate the angle in order to draw the pig at some location. So I did that. I calculated theta. It's going to be equal to, this is from my other problem, which I will link down below. So let's say theta equals, I'm going to actually have two thetas. So let's call this theta 1. Theta 1 is going to be inverse cosine, so a cos of m times g divided by t. And those are all scalars, right? Because remember, if I had g as a vector, that would not be able to take the inverse cosine of a vector because that's just not defined. You can't do that. So now I know theta based on those parameters up above. So I can put the location of the pig. So the pig is going to be, I need to start from that pivot point and then go down L sine theta and over L cosine theta and down L sine theta. So let's say this is going to be pivot.pos plus L times vector cosine theta 1 minus sine theta 1 0. And then let's give it a radius of, let's say, L divided by 20. And let's give this one a color, a yellow. Color equals color dot yellow. And nothing happened. Object, you meant object.pos.x. What line is that? Object.x is not supported. Object.x. Top.size. .y. I guess this doesn't like this. Let's just do this. No, it did. Top.size .y over 2. So it doesn't like up here. Theta 1 pig equals sphere pivot. Oh, position equals. Okay, so there's my pig. Now I just need to draw the string. So let's say string equals a cylinder. Position. Now for a cylinder we need actually 3 parameters. 1 is the starting location, 2 is the vector from the start to the end, and 3 is the radius. So the position of this is just going to be pivot.pos. And then the axis, which is the vector from the start to the end, is going to be equal to pig.pos minus pivot.pos. And then the radius is going to be equal to, let's say, L divided by 50. And let's leave it as white. And that happened. Cannot subtract a scalar and a vector. Pivot. I did it again. Pivot.pos. I'm just excited about flying pigs. It's not my fault. There we go. A little thick. Let's make that a little bit thinner. 70. That looks pretty good. Okay. So now the next thing to do is calculate the velocity or the angular velocity. And let me show you how I'm going to animate this. I know the velocity. I can calculate the velocity, and I want to animate it. So I want to make this thing move in a circle. Oh, I do want to do this. Make trail equals true. And I want it to leave dots. I don't remember how to do that. Let's see. Glow script, which is webVpython, help. Work with 3D objects, attach a trail, ball, type points. Trail type equals points. Let's try that. Trail type equals, what was it? Trail type equals quote points. Okay. So let me switch back over to the paper so you can see what we're doing here, what we're going to do. Okay, so what I want to do, the thing is going to be moving in the XZ plane. So this is, let's say that's X and that's Z. And then here it is. And I want it to move in a circle like that. So if I define that circle by the angle theta 2, then I can calculate the XZ position as R, let's call it R. It's going to be the radius of the circle R, which I actually know, I can calculate, times the vector, and this is going to be, the X component is going to be equal to cosine theta 2, the Y component is 0, and the Z component is sine theta 2. All I need to do then is to change my theta. And so theta 2 is going to be equal to, let's see. Yeah, it's going to be omega times t, right? If I start at theta equals 0 and I know the time, then I can just find the new angle. So I'm going to make a loop and loop over this and keep changing that theta, and then I can move the location of my object. I need to calculate R, I need to calculate V, or omega. So the R, I did that before. Where did I do that? R is L sine theta. So I know L and I know theta. That's theta 1, right? That's the angle that it's swinging at. And then omega is this, T M over L. Okay, so let's do that. So going back to the computer, hello. I need to do a couple things. Number one, I need a theta 2. It starts at 0. I need R. R equals L times, what did I just say was R sine theta 1, right? Where'd I put that? R equals L sine theta 1, right? Okay. And now I need t equals 0, the time, and the time step, just so I can move time. Let's say it's 0.01. So let's make this run for 5 seconds. So I'm going to say while t is less than 5, do the following. Since I want it to animate, I need this statement, rate 100. This says don't do any more than 100 calculations per second. And with a time step of 0.01, this would run in real time. So the first thing I'm going to do is to draw the location of my sphere. So I'm going to have this say the pig.pos equals, it's really just the same thing. It's going to be this. Let's see. I'm trying to think because I have that angle in there still. That's the vector. Let's find the center location. No. I'm trying to think the best way to do this. I really didn't think this thing through, in case you can't tell. There's a couple ways we could do it, but if I know the location, I can find, if I just do R cosine theta, if I know this location down here, let's find this location down here. Let's call this pig center. That's going to be equal to pivot.pos. It's a vector minus L minus the vector. I just need to go down from the y direction, and that's going to be 0 L times cosine theta 1. Right, because cosine theta 1 gives me the adjacent side of that triangle, and if I subtract that down, I'm down the middle. And I could put a sphere there, but I'm just going to leave it as a vector. So now I can say the position of the pig is going to be pig center plus R times vector. Now I can use my other thing, vector cosine theta 2 0 sine theta 2. Now I want to update the value of theta. So theta 2 equals omega, which I didn't calculate. I was going to call it W. W equals square root of T over ML. So T divided by M times L. So this is going to be omega times T. And then I need to update T. T equals T plus dt. Okay, let's see if this does indeed work. I'm a little nervous. No, it did not work. Unidentified object, pivot. It's just me. I just can't write things. That's what the problem is. I just get excited and overwhelmed, and I blame physics. Okay, so it's moving in a circle, but I obviously incorrectly calculated the size of that circle. But other than that, it's doing pretty good. Okay, so, and I didn't move the string either. So this should be L cosine theta. Why is that not far enough? L cosine theta 1. L cosine theta 1. Now, why is that not far enough? I know the length of that. I know that angle's theta, cosine theta 1. Did I calculate theta 1? I did. It's A cosine mg over t. Is that right? Yeah. Because cosine t cosine theta. Why is that not in the right spot? It should be down further. Did I have L 0.15 mg t? I don't know what's going on. Let's do this. So I have the pig right here. That's print r equals pig.pos. Let's just see what that says. And then over here, I'm going to, at the end, they're all the same. Print pig.pos equals pig.pos. So let's just see how those two values compare. So that's the starting location. It has a value of negative 6.32. See, it looks like the angle's wrong because that's not the same angle. Theta 1, I drew it at that angle. Pig equals sphere. Negative, so it's way smaller in the y direction. Why is that? Okay, here I have the pivot. The pig is pivot L cosine theta 1 minus, oh, I got that backwards. So this is sine, and that's cosine. That's why. Yeah. So that works. Now I just need to move the string. Oh, that was a dumb mistake, right? That's fine. We can make dumb mistakes. So down here, after I move the pig, I need to remove the position. So I can say string dot, I don't need to move the position of the string, just the axis. Dot axis equals pig.pos minus pivot.pos. And we should be ready to rock. There you go. There's your pig moving in a circle. And we can do even things like this. What if the tension is less? What if I change this tension to 3? Then it has to move in a smaller angle circle. Okay, I'm pretty happy with this. The only thing I might change is not keeping all the dots, just keeping some of the dots. I'm pretty sure I could do this. Retain equals 100. Let's do that. And then it doesn't keep all of them. Let's retain 50. Okay, that's pretty cool. Okay, there we go. We won. Made it. The end. Hope you enjoyed that. I kind of enjoyed it. It took a little bit more trouble than I thought it was, but this is that art part of using Python. It's really doing something artistic. We really didn't get much information from this other than the solution, but it does go along with the solution, and that makes me happy. So.